All right, hello there, everybody. It is Aaron from ACM Cyber at UC San Diego. This is a walkthrough of the educational challenge. I don't even know how to pronounce this. Case 64R for San Diego CTF 2022. This challenge is originally from SDCTF 2021, but these educational challenges that we've repurposed are designed for you to just follow along with me, have fun, and get familiar with the tools and technologies of each category. Now, these educational challenges are not worth points, so if you're part of the so-called big leagues, don't worry about it, don't waste your time. But for the beginner teams that do end up completing all of our educational challenges, they will receive a very small, very special prize to commemorate their learning. So this video is designed to walk you through that, and we'll go ahead and get started now. So this is the educational challenge in the cryptography category, meaning you're probably going to need to decrypt something. And usually easy level cryptography challenges are centric around classical ciphers rather than modern ciphers like public key cryptography, RSA, AES, etc. Rather than those, we're going to be more focused on like the Caesar cipher or Vigenère or something like that, right? So with that said, we go ahead and jump right into it. This is again the I guess the file that's hosted on the SDCTF 2021 public challenge repo. So we get all of the information about the original challenge, including some that the original challenge takers in 2021 wouldn't have, such as the original specification, the flag outright, and write-ups from those that were able to solve it and wrote write-ups about it. So if my explanation isn't great, you could always go read those. But just looking at the prompt first, some script kiddie just invented a new encryption scheme. It is described as a blend of modern and ancient cryptographic techniques. Can you prove that the encryption scheme is insecure by decoding the ciphertext below? And then it gives us a piece of ciphertext. So again, this ciphertext is going to be different than the one that you have. And this flag that you get from solving along with me is going to be different than the one that you get. You really do have to follow through with the challenge using the flag provided to you in the 2021 version of the prompt. But the process should be pretty much exactly the same. So with that said, let's go ahead and take a look at this. Now, when I want to do this kind of challenge where I'm just given a piece of ciphertext and I know it's the flag, one of the best ways to kind of experiment and try different things is by simply going to the tried and true browser-based tool CyberChef. From this, we will be able to try a lot of different things. In fact, if the encryption is simplistic enough, it will even just magically determine it. But in this case, we can see that it can't really. Usually it will detect things like if all that's being done is a base 64 encoding, or if all that's being done is a single Caesar shift, it will be able to detect that and magically undo it. Now, the problem here is that because it's not detecting it, we know that it's not as simple as that. There has to be a composition of multiple things. And we can even just verify it by doing like from base 64. Unfortunately, we get a lot of unprintable garbage, which is non-ideal. That means that we need to do more to this before we actually end up shifting it. And the reason why I talk about shifting is because from the name, I do get the feeling that base 64 is involved. But I also get the feeling that the Caesar cipher is involved. Because obviously the word Caesar is kind of here, but also so is an implication of base 64. And that would coincide with a blend of modern, which is to say base 64, and ancient, which is to say Caesar, cryptographic techniques. So if both of these are being applied, I do wonder about how they could even be composed, really. And the problem comes from the Caesar cipher, right? The Caesar cipher is only defined on the alphabet, and it works like, A through Z. And if I have like an A and the shift is 2, I shift it from A to B to C. And I shift B to C to D, and so on and so forth. Like I basically just shift the alphabet over. I'm sure you're familiar with the Caesar cipher if you're watching this video, but Unfortunately, uh, it's not defined on a lot of base 64 characters. So for example, we have here uppercase and lowercase letters. We have numbers. We even have symbols, which are particularly difficult for it to deal with. Now, it is the case that all of the symbols here are defined in the base 64 standard. So it seems like this is going to be, the first step is going to be undoing base 64. But when we do that, we get garbage. So it's difficult. But then we go the other direction. We think, like, imagine we have the plain text, right? It's SDCTF and then curly braces and then some stuff. How would you apply the Caesar cipher to that? You'd be fine for the letters and the numbers, but you wouldn't be fine for like curly braces. Like, what is the Caesar shift of a curly brace? And so, I mean, you can try this all out. You can go to like the C's, or I guess they call it ROT13 on this, and then you can customize the exact one. But I mean, I can shift these all day long, and unfortunately, I don't seem to get anything that's legible or even fully printable. So it doesn't feel like I shift this and then decode it. But the other way wouldn't really make sense, because when I decode it, I don't get printable characters at all, which is almost impossible for the Caesar cipher to deal with. So I'm kind of at an impasse. Now, this module, though, is not intelligent enough for our purposes, as it turns out, right? Because all it can handle is lowercase, uppercase, and numbers. And while I have all of those, I also have these symbols in here as well. And so maybe it is a true merger of the two, right? Like, what if this is some version of Caesar cipher that knows how to shift the plus and the slash, right? Like, what if it operates this shift on the actual base 64 alphabet, which, as you can see here, is A through Z uppercase, followed by A through Z lowercase, followed by 0 through 9, followed by plus and a slash, followed by equals, but equals is a padding character. So this is our alphabet. What if we shifted that and then tried to decode it? And so, unfortunately, in order to do that, CyberChef is not really sophisticated enough. So we're going to need to probably write some code. I mean, we could definitely do like the raw substitution cipher, but it would start to get complicated. And I think we could do more faster with Python or any programming language. So let's go ahead and give up and try again, but with Python this time. So opening up Python, I first want to go ahead and put in my ciphertext, right? So here's my ciphertext. Whoops, there it is. Great. Now I want to do some stuff to it. I know that I'm going to be decoding base 64, so let's go ahead and import the base 64 module. And I can go ahead and just quickly verify that this works by simply printing base 64, and then I think it's B64 decode is the name of the function, and then you just pass it the ciphertext. So when I do this, let's go ahead and run this program now, which I think I can do by simply typing Python CipherPy. It shifted it, or no, it didn't shift it. It decoded it. But again, we're stuck with a lot of unprintable garbage. So this isn't quite working. But again, this is on this particular unshifted alphabet. What if we had the base 64 alphabet, which I believe, as mentioned, was uppercase, then lowercase, then numbers, then plus and slash. I don't have that. I don't feel like typing that out. So let me see if I can just quickly Google base 64 alphabet. I think this one has it. Yeah, so I'll put this over here. This is the uppercase, followed by the lowercase, followed by the digits, followed by the special symbols. All right, there you go. And then once we have that, let's go ahead and move this back over. Great. So once we have this alphabet, can we shift this ciphertext instead of the normal Caesar cipher, which is only defined on like this, if I shift this whole thing before decoding it, what do we get? And the problem is that, well, unlike the normal Caesar cipher, which is 26 possible shifts, this is the base 64 alphabet, which fittingly has 64 possible shifts. Rather than, you know, look at each of them and like try, I'm just going to have this program print all of them. So let's go ahead and do that. So let's get rid of this. And what we're going to do is just for each shift in, and then we're going to iterate between like 0 and 64. We want to generate a shifted string. So this is us shifting the ciphertext by each possible shift using the alphabet that we've created up there. I'm gonna just basically use like a, what do they call it, list comprehensions to quickly do this. So for that, it would be like C for C in ciphertext, right? And this basically generates the, this basically creates like a functional, like this character, this is over each character in the ciphertext. But instead of just returning each character, I'm going to shift it. So now I have to shift this C right here. The way that I'm going to do that is by getting the index of it in the alphabet. So I think that would be .index to get the index of it. And then we shift it. But then we have to make sure that if we go over 64, we wrap around. And so the way that we do that is we just mod it by 64. Let's make sure our order of operations stays consistent. And then once we have that new shift number, we need to convert that back to the physical character, which we do by simply indexing into our alphabet again. And this should be the shifted string. Afterwards, we're going to print each shift followed by the shifted string. And then I think we'll decode it, but let's go ahead and make sure that that works. So this prints 64 different shifted versions. None of these really stand out to me. I mean, it's all still just the base 64 alphabet, so we will want to decode each of these. And for that, we will do, again, base 64.b64 decode on the shifted string, and we will run that. And so, like, for example, here's 54. That's it shifted by 54, and then that's the byte string that you get when you decode it. Let's just go ahead and scroll through this and look for that right there. So we totally have a match. If you shift the base 64 alphabet by 14, the resulting decoded string will be the flag. So there you go. That really is a combination of the two. The flag in my case is SDCTF, obscurity ain't security. Yours will be different, and it might even have a different shift. I don't know. So anyway, yeah, go ahead and submit your flag. I hope that you learned some of the principles of solving cryptography challenges. You'll definitely be using a lot more Python for the more advanced challenges, which is why I used it for this relatively simpler one. But I hope you have a wonderful rest of your competition, and I'll see you later.